Welcome back, everyone. Yesterday we learned about the areas and perimeters of parallelograms and triangles. Today we are going to learn about the areas of trapezoids, rhombi, and kites. So first let's start out with trapezoid. A trapezoid, if we want to find the area, I want you to first notice that two trapezoids together can make a parallelogram. Now if we wanted to find the area of this parallelogram, the base could be represented by B1 plus B2. The height is h. Notice the height for the parallelogram is the same as the height of the trapezoid. So if we wanted to find the area of this parallelogram, we could take the base times the height, or in other words, B1 plus B2 times the height, h. Now, with this being cut in half and creating a trapezoid, if we want to find the area of just one of those trapezoids, we would take the area of the parallelogram and divide it by 2. So to find the area of a trapezoid, we have the formula B1 plus B2 times the height divided by 2. Another way to write this is 1/2 times the height times B1 plus B2. Another way to think about this, we know that the average of the bases, B1 plus B2 divided by 2, this is the same as the length of the midsegment. So if you take the midsegment times the height, that will give you the area of the trapezoid. Let's do a problem together. This says one of Brianna's isosceles trapezoid-shaped totes is shown. Find the amount of material used to make the side shown. So in order to find it, it's a trapezoid, so remember the bases are the parallel sides. That would be these. So I know B1 and B2. It doesn't matter which one I use for B1 and which one I use for B2. But I get 28 centimeters and 58 centimeters. Now I also need the height. In order to find the height of this, I need to look at one of these right triangles. So I know that these right triangles would be the same length on both sides. From this point to this point is 28 centimeters. 58 minus 28 is 30. So that means each of these triangles has to have a base of 15. Now if the base is 15 and the hypotenuse is 30, you can use Pythagorean theorem to solve this. But another way to solve it, whenever I see that the hypotenuse is 2 times the base, I know that this is a 30, 60, 90 triangle. So this has to be 2k. The side across from the 30 is k, which means that the height is k times the square root of 3. Since k is 15, I know the height is 15 square root of 3 centimeters. Now that I have all my variables, I can use my ESSA method. So the equation is area equals 1/2 times the height times the sum of the two bases. So I get 1/2, the height is 15 square root of 3, the first base is 28, the second base is 58. Next, the next S stands for solve. So I'll plug this into my calculator. 0.5 times 15 square root of 3 times 28 plus 58. That gives me an approximate answer, 1,117.17 centimeters squared. So my answer with units, the amount of material is about 1,117 centimeters squared. I want you to try the practice problem below. See if you can find the area of the glass used to make the windshield of the van. Here's the correct answer. Now we're going to do a challenge problem. It says Amelia designed the pennant shown for her team. Find the area of the shaded portion of her team's pennant. So first off, I noticed that this shape is a trapezoid. Now, it did not give me the length of both bases. I know this base is 10 inches, but I do not know the length of the other base. Using these as the bases, I can use 4 as the height since it makes it perpendicular to the bases. So I need to figure out the length of base 2. The length of base 1 is 10 inches. Let's cut off a right triangle inside of this trapezoid. So, if you're in the honors class, I want you to try to solve this. We will go over this tomorrow. Otherwise, you can try it, but I won't require that you know how to do it. All right, let's talk about the areas of rhombi and kites. For the area of a rhombus or a kite, we use the formula 1/2 diagonal 1 times diagonal 2. Another way to think of that is diagonal 1 times diagonal 2 divided by 2. Although a rhombus and a kite are a bit different, remember a rhombus is a type of parallelogram where a kite is not a type of parallelogram, they do have the same formula for their areas. Let's do an example together. Find the area of each rhombus or kite. This figure shown is a kite. I know the first diagonal is 8 meters. The second diagonal is 15 meters. So my equation, A equals D1 times D2 over 2. Substitute. D1 is 8. D2 is 15. Again, it does not matter which one you use for diagonal 1 versus diagonal 2. And finally, the next S stands for solve. So we get 120 when we do 8 times 15 divided by 2, which is 60. So my answer plus units, I have the area is 60 meters squared. Let's try another one. This one is a rhombus. So this one's a little different because they only gave us half of the diagonal. So for this one, I know a rhombus has diagonals that are bisecting. So I know if that half is 10 feet, the other half of the diagonal must also be 10 feet. That gives me a total of 20 feet for the first diagonal. Similarly, the other diagonal, they only gave me half of it, so the other half's also 12 feet. That gives me a total length of 24 feet for the second diagonal. Again, it doesn't matter which one you use for D1 or D2. Next, we will use our ESSA method. E stands for equation. I know the equation for the area of a rhombus is 1/2 D1 times D2. Substitute in your values for D1 and D2. Next, S stands for solve. 1/2 times 20 is just 10. This is kind of easy to do without a calculator. 10 times 24 is 240. So my answer plus units, the area is 240 feet squared. All right, there are some practice problems for you below. Here are the correct answers. Now let's try to use this to find missing measures. It says one diagonal of a rhombus is twice as long as the other diagonal. If the area of the rhombus is 169 meters squared, what are the lengths of the diagonals? So first, let's come up with our equations. I know the area formula for a rhombus is 1/2 D1 times D2, or D1 times D2 divided by 2. I also know that one diagonal is twice as long as the other. It doesn't matter which one you use as the longer diagonal, but I know one has to be 2 times the other, so that would be 2D2. Next, let's use substitution. I know the area is 169, and I know D1 is 2 times D2, so I get 2D2 times D2 over 2. I'm plugging in 2D2 for D1 using substitution. Now I have to solve. The first step to solve this is to multiply by 2 on both sides to get rid of the division by 2, or the 1/2. So I get 338. Well, actually, before we do that, let's pay attention. I see a 2 in the numerator and denominator. I can go ahead and cancel those out. So I get 169 equals D2 squared, because D2 times D2 is D2 squared. Let's go to the other side here to give us more space. How do we get rid of a squared? Well, we have to square root both sides. When I take the square root of 169, that gives me 13. Remember, when you square root both sides, you have to do positive or negative. But in this case, it doesn't really make sense to have a negative value, since the diagonal of the kite, the rhombus in this case, cannot be negative. I know that the diagonal has to be 13. Now, I can use my other equation that says D1 equals 2 times D2 to find the length of my other diagonal. Substitute in D2 is 13, so that you can get D1 is 26. Finally, for your answer with the units, the diagonals are 13 millimeters and 26 millimeters. How could you check your work on this one? All right, try the practice problems. Here are the correct answers. Here's A and B. Finally, I want you to reflect on this question. Antonio and Madeline want to draw a trapezoid that has a height of 4 units and an area of 18 square units. Antonio says that there's only one trapezoid that will meet this criteria. Madeline disagrees and thinks that she can draw several different trapezoids with the height of 4 and an area of 18 square units. Is either of them correct? Explain your reasoning in 1 to 2 sentences. You can also use a picture if it's helpful. Tomorrow we're going to be learning more about areas and perimeters. The next shape we will be talking about is the area of a circle. You might already be familiar with the formula. If you are, that's great. If not, we'll go over it tomorrow. Talk to you then. Bye.